Now this is the explanation for assignment number three. So this assignment is asking for just two questions. Distance that the piston has traveled from the top dead center to the end of the combustion. Okay. Let's see what happens on these positions. Let's remember that when we have the combustion, the piston is in the top position. Let me see if you can see me. Okay. Yes. So we have this position. This is the crankshaft. And there's a variable which is called lowercase s that is measuring this instantaneous distance. It's not a stroke, it's a smooth stroke. It's called the piston position. Okay. The distance is from the connection with the piston to the center of the crankshaft. Okay. So we have first this distance r, and then this distance which is the radius of the connecting rod, excuse me, of the crankshaft. R, it's the length of the connecting rod. And this is information from the problem. It's 16.6 centimeters. A, it's already calculated. We did it on class, but it's the half of the stroke, because the diameter of the stroke, the diameter of the crankshaft, it's one stroke. It's a capital S, different to this one. So it's an A, and this is also from previous over 2. Excuse me. From previous calculations, 4.3. So if we are looking for this S will be R plus A equal 16.6 plus 4.3, which is 20.9 centimeters. But I have an answer. Question: the distance that the piston has traveled from the top dead center. This is the top dead center. Bottom dead center. So what about this distance? Okay. We have it when we go to this second diagram that we saw during class. And we have this crankshaft here. The original position on the top is here. Let me do it like this. Yeah, it's here. And the piston has moved here. Okay? We don't have now, the original position was vertical. So now the connecting rod it's in some position here. Okay. In US we have it's changing here. The previous position, the previous S was right here. So there's a certain distance. The piston has moved from the top to some position here. Same distance here. Top dead center, bottom dead center. Now we know from also from the concepts that we review and also from the text here, this angle of the crankshaft theta it's equal 20 degrees. Okay. This is R and A. Well, we cannot use this R and A to find this S directly. We have to work a little bit in some algebra for finding this S. The equation is already given on the operation characteristics in the file that I already sent to the students. They have it. I can send it to you also, to everyone. But the point here is that I really wanted the students to see the reason of this S, not only just using the formula, but knowing where this formula comes from. So what I did with them is showing them this triangle in a bigger figure. Here. This is R, this is A, and this is the angle, 20 degrees. Okay. And dividing this triangle into sections, two right triangles. Okay. This is 90 degrees and 90 degrees. And this is S. The full distance is S. Just repeating what is S, what is here. So, according to trigonometric functions, this distance from here to here, it's A cosine the angle theta. This it's A sine theta. Let me see if there's some space. Yes. So to find this other section here, we have to work a little bit more in using Pythagorean theorem. Okay. Remember, the Pythagorean theorem is that we have this triangle, and we have A, B, C, which is the hypotenuse, the C, and the sides opposite to well, we don't have to use right now the angle because we don't have an angle here. So just remember that c squared is equal a squared plus b squared. Since this one is one of the sides, and we already know the other one, the other side of the triangle, then we have to go to find one of the sides. A squared is equal c squared minus b squared. A it's equal the square root of c squared minus b squared. Okay? A similar situation. R is c, b is a sine of theta. So this side will be the square root of r squared minus a sine squared. Also, they don't have to do this analysis. I'm just showing it to get kind of the reason of the equation. But the equation is already given on the notes. A squared a sine squared. So the S will be this concept, or this distance, plus this distance. S is equal a cosine of the theta plus r squared minus a sine of theta squared. What is the reason of having this? A, it's a dimension that we already have, 4.3. Theta, it's 20 degrees. R is the connecting rod, which is 16.6. A, once again, is radius. So this distance D, we can call this one S1 and S2. Is the difference between S1 minus S2. Okay. So this one will be equal to S1, which is R plus A, minus all this A cosine theta plus R squared minus A sine theta squared. This is the answer for the distance. Okay. Now, just would like to repeat it. You don't have to do any of these equations. This one, it's already on the notes. I can tell you is the equation. Let me tell you which one. It's equation 1.3. Now I will send you the file, okay? This equation. And also this one, it's part of the equations there. It is, well, it's in the diagram. So we can see that R, it's R plus A, it's S1. Okay? So this is only the equation how we solve. Okay? Now for the second part, calculating the volume of the internal combustion engine. The question, let me erase this section. B. Maybe it's a little bit more here. Volume in the internal combustion engine and in the chamber of combustion question is at the end of the combustion. Okay, so let me put yes. At the end of the combustion. Okay. When the piston is on the top dead center, there is a volume on the chamber of combustion that is not touched by the piston. It's just this volume is where the mixture of air and fuel is in the chamber to be exploded. This volume is called PC, which is clearance volume. If we remember what happened after combustion, the piston moved a little bit downwards. Okay, so we do here, and this one is here. So when it moved a little bit downwards, it just left an additional space, an additional volume to the one that already exists, which is the clearance volume. If we do it in 3D, we have this clearance volume plus the volume that the piston left after combustion. So we have PC. This one it's already calculated on the class or in previous problems, in the same problem we did it on class. And this value of displacement, I call it EC. EC means, let me on it, instead of D, just EC. It's end of combustion. So this EC will be again calculating the volume of a cylinder. So we have, remember, area times height of only this small volume. The area it's pi over 4. The diameter, which is the bore, and we already have it, it's 8.6 centimeters, times the height of this cylinder. It's like a small slice. So this height is this displacement. So A, P, so it is pi over 4 p squared times d. This d is the one that we calculated on the previous letter. So the total volume will be equal VC plus VEC. And that's all. Thank you very much. Just let me know if you have more questions. And I'm fully happy to answer any questions. This thing I really love, internal combustion engines and mechanical engineering. It's my life, so I just love to teach it. Have a great day.